We started our today's session by looking at the means. We first looked at the average in 3 years, 1919, 2000 and 2010. We also looked at average per country in all those years. But sometimes looking at the averages is not enough. Just finding the mean value is not enough. It is especially relevant in cases where you're measuring something where you don't know, is it much, is it little? And this is exactly the case here. Without additional knowledge, we cannot really tell what this mean actually means. Is it good? Is it bad? Are we fine on our GHG levels or not? Usually, to figure this out, we need to compare to something. In this test and until the end of this lecture, as well as the whole next lecture, we will be talking about the means and we will be trying to figure out what do those means mean. Now we'll start simple with the first test. In this test, we will be comparing the mean of our sample to some arbitrary point. This is called a one sample t-test. What one sample t-test does is that when you look at the mean and you already have some arbitrary point in mind, you, for example, looked up somewhere on the internet and it looks like a country of a specific size, let's say the size of Austria, on average should produce this much of GHG a year. And now you would like to compare this arbitrary number to the numbers to the mean in our sample. I don't have this number, so we will have to create a benchmark, this benchmark number ourselves. Let's start clicking. So first we go to our long data. In this case, it doesn't really matter which one we're using. And let's create a pivot table. Again, we're keeping it orderly. So let's say this is our... This is a one sample t-test, so let's say one sample t-test, and let's say pivot. So let's include all the parties, all the countries or values that we have here into the filter and throw in values here. So now it shows us the sum of all from all the entries that we have. Let's take the average. And you know what, let's throw in the parties here. It's easier to filter like this. Now we select and let's deselect all of them and select only European countries. Or, well, European countries doesn't mean union. Let's just select some European countries quickly through the list and take the average so that we have some benchmark. So we have Austria, Belgium, Bulgaria, Croatia, Cyprus, Czech Republic, Denmark, Estonia, we will not take the union together, Finland, France, Germany, Greece, Hungary, Ireland, Italy, Latvia, Liechtenstein, Lithuania, Luxembourg, Malta, Monaco, Netherlands, Norway, Poland, Portugal, Romania, Slovakia, Slovenia, Spain, Sweden, Switzerland, that's what I meant by non-European Union really, and United Kingdom. So now we have average for all of these countries, and in the grand total we have an average for all of them. So we selected, let's have a look. We select all of them and we have a count 32 countries. So I might have forgotten one or another there, but for the purposes of this example, it's not so important. For political purposes, of course, it is very important. So let's select this number and copy it here somewhere on top so that we have it. Now let's throw in the party out and let's try to print all the values, let's say, for one country. So we will need to have years here and all the average values. This is for everything. So now let's throw in the party here into the filter. And let's filter out one country. Let's say Czech Republic sounds good. So, and you see that Czech Republic has 141,500 in the average GHG value over the years, and our average across all countries was almost 150,000. So the question is, if this is our benchmark, let's say this is what we're expecting a country of size of Czech Republic to produce a year, let's say this is a mythical benchmark that we looked up somewhere in the internet, we would need to assess whether this value, 149.7 thousand, is bigger, significantly bigger than 141. So is Czech Republic in this scenario doing okay because they're under our benchmark value, or maybe this value is not so far, not so different after all? How do we do that? Well, to basically say whether this value that we have here is different from the average value that we have here, we need to slap a p-value on it. So we will compare the mean in our sample over the years in Czech Republic to our benchmark, to one number that we selected. We decided, based of course on some common sense. In this case, we somehow calculated this number. It could be a number that means something to you, or a number that you looked up on the internet and you can justify why you're comparing to this number. And we will compare and say whether one is significantly different from another. How do we do that? We play with our data plugin. So we select data, and we will select a t-test sample assuming unequal variances. This is not actually what we're doing. We're doing a one sample t-test, but we're hacking it through. Let's roll back a second. So we're going to compare this number. Let's copy it here twice. That's the way how you hack through it. And we say, this is our arbitrary point and this is our average point. Now we can use the labels. Again, data and analysis, we select a line that says two sample assuming equal variances, even though remember we're doing a one sample t-test. And we select the values. We select again control down. So this is a problem when we have a grand total. So let's edit it to 32 so that we only have until this line, and then this range we are including these two values. But you know what, let's include labels, that's much neater. So shift it one way higher. Now it starts with B3, so we have our values here, and let's not forget to tell Excel that we have labels, and click OK. So we are receiving one more sheet. Let's drag and drop it neatly and arrange the columns. So double click to make it wider. What do we have? It shows us that we're comparing our average value per country, Czech Republic, to our arbitrary value. And now we scroll down to a t-test. This is the line that we need to look for, this one with the two-tailed t-test, and the value is significant. So there is a significant difference between 141,500 and 149.7 thousand, because p-value is less than 0.05. So this is exactly what we're doing. We select a point, some point that makes sense, and then we're comparing it to our sample. In this case, we use the pivot table to generate a small sample for Czech Republic for the last 29 years, starting with 1990 and finishing with 2018. Now it's your turn to try it out and compare some arbitrary point to a specific country. Keep on clicking to see the exact instructions of the task.